Welcome to the astonishing world of black holes, the most enigmatic and extreme phenomena in the universe. Did you know that at the heart of nearly every galaxy, including our own Milky Way, lies a supermassive black hole, weighing millions or even billions of times more than our Sun? These titanic objects are invisible to our eyes, cloaked in perfect darkness, yet they control the motion of stars, influence the structure of galaxies, and perhaps hold keys to hidden dimensions of reality. In this journey, we'll unravel what black holes truly are, how they form, the types that exist, what makes them so bizarre, and some of the most groundbreaking discoveries, from capturing the silhouette of a black hole to hearing the echoes of their collisions through gravitational waves. But before we dive in, consider this. What would really happen if you fell into a black hole? And could these cosmic beasts be tunnels to other universes? Let's find out. At their essence, black holes are regions in space where gravity becomes so overwhelming that escape is impossible, even for light. Because light can't get out, they appear completely black. But how does such a thing come to be? To understand that, let's think about gravity. It keeps your feet on the ground, holds planets in orbit, and binds galaxies together. But when a massive amount of matter gets compressed into a tiny volume, the gravitational pull at the surface intensifies dramatically. If the collapse is extreme enough, like when a massive star dies, gravity wins completely. A black hole is born. Every black hole has a boundary known as the event horizon, the point beyond which nothing can return. Cross that threshold, and you're on a one-way trip inward. Even light, the fastest thing in the universe, can't make it back out. It's like drifting toward the edge of a waterfall. As long as you're upstream, you might paddle away. But once you go over the edge, past the event horizon, there's no turning back. What lies at the center of a black hole? That's where things get truly bizarre. According to current theory, all the mass collapses into a single, infinitely dense point called a singularity. At that spot, the known laws of physics break down entirely. So how do these cosmic monsters come into existence? The most common way is through the collapse of massive stars. When a star that's at least 20 times more massive than the Sun runs out of fuel, it can no longer hold back gravity with nuclear fusion. Its core collapses, and if it's heavy enough, it becomes a black hole. But that's just one path. Some black holes, called primordial black holes, are theorized to have formed in the earliest fractions of a second after the Big Bang, born from extreme density fluctuations in the infant universe. Then there are the giants, supermassive black holes. These lie at the centers of galaxies and can weigh millions or billions of times the mass of the Sun. How did they grow so enormous? Did they form small and grow over cosmic time? Or were they born already huge? That remains one of astronomy's great mysteries. There's also a category in between, intermediate mass black holes. These elusive objects may bridge the gap between stellar and supermassive black holes, though confirming their existence has proven difficult. And finally, there are micro black holes, purely theoretical objects that might be smaller than atoms. Though we haven't observed them, they're fascinating to physicists, probing the very foundations of space and time. Let's break it down into categories. Stellar mass black holes, created from the death of massive stars. These typically range from a few to a few dozen times the mass of our Sun. Intermediate mass black holes, rare and mysterious. These may weigh hundreds to thousands of solar masses, potentially acting as missing links in black hole evolution. Supermassive black holes, lurking in the hearts of galaxies. They tip the scales at millions or billions of solar masses. Primordial black holes, hypothetical remnants from the early universe, possibly tied to the mystery of dark matter. Each type presents its own puzzles. Why are intermediate mass black holes so hard to find? Could primordial black holes be the key to understanding the hidden mass of the cosmos? Black holes challenge our understanding of reality in astonishing ways. Take the event horizon. If you fell toward a black hole, someone watching from a safe distance would see you appear to slow down and freeze near the edge, your image stretching and fading into red. But from your perspective, you'd fall straight in, with no warning as you crossed the horizon. Then there's time itself. Near a black hole, time runs differently, slower, compared to the outside world. This phenomenon, known as gravitational time dilation, means that spending time near a black hole could be like skipping into the future. Go in orbit for a while, come back, and years may have passed for everyone else. And here's the kicker. Black holes may not last forever. According to Stephen Hawking, they emit a faint glow, now known as Hawking radiation, and slowly lose mass over trillions of years. In the far future, even the most massive black holes might simply evaporate into nothingness. In 2019, we achieved a cosmic milestone. The Event Horizon Telescope captured the first ever image of a black hole's shadow, a supermassive black hole in galaxy M87, over 50 million light-years away. It was a stunning confirmation of Einstein's predictions. Meanwhile, instruments like LIGO and Virgo have opened a new window to the cosmos by detecting gravitational waves, ripples in the fabric of spacetime, produced when black holes collide. And space missions like NASA's NICA and ESA's upcoming Athena, giving us sharper views of black holes' surroundings, helping us understand how they feed, grow, and influence the galaxies they inhabit. So what comes next? Could studying black holes lead us to a theory of everything, a way to unite quantum physics and gravity, or even hint at the existence of parallel universes? Black holes aren't just cosmic anomalies. They might hold the key to some of the deepest mysteries in physics. One of the most puzzling questions is the information paradox. According to quantum theory, information about particles can never be destroyed. But when something falls into a black hole, it seems to vanish completely. How can that be? If black holes erase information, it would challenge the foundations of physics. Could this paradox be a clue to a deeper, unified theory that merges quantum mechanics with gravity, a long-sought theory of everything? Some theorists take it even further. They suggest that black holes might serve as bridges between universes, through structures called wormholes, theoretical tunnels in spacetime that could connect distant points in space or even different realities. Could a black hole actually be a gateway to somewhere or something else? While highly speculative, this idea continues to inspire bold theories in physics and iconic scenes in science fiction. If black holes don't emit light and are, by definition, invisible, how do we detect them? Astronomers spot black holes by observing their gravitational effects on nearby matter and light. When gas and dust spiral toward a black hole, they form a hot, glowing accretion disk that radiates powerful X-rays. These emissions can be detected by space-based observatories like NASA's Chandra X-ray Observatory. In binary star systems, a black hole can siphon matter from its companion star. As this material falls in, it heats up and produces brilliant bursts of radiation before crossing the event horizon and disappearing forever. At a much larger scale, supermassive black holes can power quasars, the brightest objects in the universe, as they devour surrounding matter in galactic centers. And now, we have a completely different way to observe black holes: gravitational waves. When black holes merge, they send out ripples in spacetime itself. Instruments like LIGO and Virgo have allowed us to detect these ripples directly, opening an entirely new era of astrophysics. You don't have to look to distant galaxies to find a black hole. There's a supermassive black hole right in the center of our own, the Milky Way. It's called Sagittarius Asterisk, and it's located about 26,000 light-years from Earth. Sagittarius Asterisk has a mass around 4 million times that of the Sun, and in 2022, astronomers used the Event Horizon Telescope to capture the first image of its shadow, revealing the monster at the heart of our galaxy. Though this black hole poses no threat to us, studying it helps scientists understand how galaxies grow and evolve around such massive gravitational anchors. Black holes may be destructive locally, but they play a constructive role in shaping the universe. They regulate the growth of galaxies, influence how stars form, and may have even played a role in shaping the cosmic web, the vast structure of the universe. Their immense energy output can trigger winds and jets that affect star formation for light-years around. And when two black holes collide, the resulting explosion of gravitational energy is almost unimaginable, releasing more power in a fraction of a second than all the stars in the observable universe combined. Yet these events are utterly silent to our ears and invisible to our eyes, unless we use gravitational wave detectors to sense the tremors they leave in the fabric of spacetime. So let's bring it all together. Black holes are regions where gravity becomes so strong that nothing can escape, not even light. They form mostly from the collapse of massive stars, but others may have originated just after the Big Bang. They come in several types: stellar mass, intermediate mass, supermassive, and primordial. Their behavior challenges our understanding of space, time, and information itself. Recent discoveries, from the first black hole images to gravitational wave detections, are revolutionizing how we study them. But we're only scratching the surface. Could black holes reveal how quantum physics and gravity truly work together? Could they help us understand the beginning or the ultimate fate of the universe? What do you think lies beyond the event horizon? Could a black hole lead to a new universe? Share your thoughts in the comments. I'd love to hear your ideas. And if you enjoyed this journey into the depths of cosmic mystery, don't forget to subscribe for more stories about space, science, and the nature of reality. Check the description for more resources on the Event Horizon Telescope, LIGO, and the missions helping us uncover the secrets of black holes. Until next time, keep exploring and keep wondering.